separate process. And as you can see in the bottom left corner, there's a task key for about how we estimated the time for each of these tasks for anywhere from very complex assemblies to simple assemblies.
Moving on from manufacturing, another important aspect of facilities design would be personnel requirements. One such personnel requirement would be space that would be needed for bathrooms. There are many keys and charts for which you can gather a certain number of bathrooms needed per number of employees. Here we have assembled a simple spreadsheet that will tell us what is needed, and all you need to do is simply put in the number of employees your facility will be hosting, and it will output the amount of space, the number of doors, the amount of lavatories, water closets, and so on and so forth for your number of employees, which is a crucial aspect in facilities design. Once we have compiled a bunch of stipulations and requirements in order to create our diesel engines, we need to know if our design is going to be feasible. We do that by breaking up our costs into fixed cost, that is, the cost of machines, equipment, building, and overhead that won't change no matter how many units we produce. And we also have variable costs, and these are costs that are going to be per unit. That is, as the units increase, so will our variable cost. Once we have compiled a detailed list in our spreadsheet of different variable costs and overhead costs, we need to make sure that our company can break even. That is, we have to make sure that we make enough money as much as or more as we are spending. Here we have laid out different types of costs year by year, and we have compiled it so that we can measure one line on the graph as our cost line and one line as our profit line. As you can see, we do break even. However, our profit margin, that is the difference between our revenue and our costs, is not very large. An important aspect of this cost break-even analysis is our cost index. Each one of these cells is reference to another part in the spreadsheet where we delved into the details of the different costs that are going to be involved with this facility.
Next we have machine defects. As you can see, once again we have our assembly names listed, and this time we show their defect rate for each of these machines. As you can see, there's also comments on the very right talking general comments for what this machine, what's the defect on this assembly would typically be. As you can see down on the bottom, we have the 1,000 engines per month. And based on this equation, we do 1,000 divided by 1 minus all of these defects. 1 minus this, 1 minus this, 1 minus this, all the way down, and we find that we will need to produce 1,293 point some engines, which is 1,294, in order to successfully have 1,000 engines produced. Next, we will have Dean explain the Simio model of our production facility.
This is our Simio model. You see this is a 2D picture. We have all the servers, not all of their names popped up, but as you can see, one is the crankshaft. We got the cooling system 1, fresh air temperature, and electrical system 1, full system 1, a bunch of these different ones. Every one is actually here and it goes in an S shape. So follow my cursor, it goes down this way, back down around, another S, and then it goes to storage, and then where it can be shipped out to this garage door. It might be easier to see in a 3D picture, but all of these servers have input, random input. So I know that this first one is 10, and I know that these electrical ones are around 0 because things pretty much go in and out of it. Can't remember all the numbers of a bunch of these, but all of them have different inputs, and it gets bottlenecked actually in the beginning. 10 minutes, or 10 minutes is the longest it takes for anything else to get through here. So there will be no bottleneck down the system, since it does take the longest just to get this first engine on the line. So I'll show you in the 3D model. This is the 3D model. Gives you some better sight of the storage, the garage doors, all these machines, and I think I also have the experiment on here. This just shows you what one one server would look like, the belt guard, for example. We have the utilization and the time takes to process, time started. We have a bunch of the throughputs, and we found out that this is just for like 8-hour workday. So we found out through all this that the total number that goes through is about 48, sometimes 50, which is right on the numbers we want to hit per day. Since we want 1,000 per week, 1,000 per month, it works out pretty well getting 50 out per day within the workday. So that's like 20 working days. So it works out pretty well.